Hi, I'm Richard Lang. Welcome to AEROPS. Today, our third video in the equipment series is about cameras and imaging. We're going to look at the three different types of cameras that are used in the field for UAP investigation and paranormal work. Aerospace Research Operations is an organization that's domiciled in Virginia and registered with the State Corporation Commission. Also known by the acronym AEROPS, which is a scientific research cooperative that's focused on unidentified anomalous phenomena and the associated high strangeness and paranormal effects that typically result after an encounter. There are three basic types of cameras that are used in the field when researching UAPs or other types of anomalous phenomena, and they're all different. We're going to start with general photography, digital single-lens mirrorless cameras. Then we're going to talk about thermal imaging. They're monoculars that are handheld infrared scopes. Finally, we'll talk about night vision, starlight night vision cameras. Starting with general photography, pictured here is a Canon EOS R10. It's a digital single-lens mirrorless camera. The mirrorless cameras are smaller, lighter, and more reliable than the original DSLR cameras because there's no mirror and moving parts. They're powerful, sleek. These cameras offer high sensitivity, unmatched image quality, and fast overall performance in an easy-to-carry, advanced, lightweight, compact design. I use a Canon 18 to 150 millimeter f3.5 lens that fits comfortably in your hand. The camera has a capacity to shoot 15 frames per second. It's got a 24.2 megapixel sensor with an ISO rating of 32,000, which delivers stunning resolution photographs taken day or at night, even in very low light. It's got lightning-fast autofocus technology with subject detection that lets you keep your eye on the action while it keeps your subject crystal clear in focus. You can shoot professional grade 4K video with subject detection and subject tracking for quicker shooting and stronger focus. But remember, these digital mirrorless cameras can only shoot video for around 30 minutes. Longer interviews that you might want to do would be better served by using a camcorder, which we're going to talk about in the next video. On this slide, you can see that the viewing screen folds around front so that you can use it while you're vlogging, basically photographing yourself, and you can see your image and what's behind you. The camera has a switch on the bottom of the body to switch from autofocus to manual focus. We've recommended this in some cases where individuals trying to photograph a UAP with a typical cell phone, the image won't focus. It'll go in and out of focus. So what we recommend is switching to the manual focus setting and manually focusing it. Gives you a better chance of capturing an image. Also, you'll see that there's a remote control that actually fits in the handle so you can operate the camera while you're vlogging. But the remote is removable and it has buttons for controlling the wide angle and zoom as well. You can see on this slide that there's a manual focus ring at the end of the lens. In the middle of the lens, as indicated here, is the zoom control, and you simply rotate it to bring the subject closer or more wide angle. There's a shutter button you can see, and there's a pop-up flash. The program control is basically a dial that allows you to select different types of programs, like aperture priority, where you set the aperture and the camera adjust the shutter to compensate, or shutter priority where you may want to use a very high shutter speed to stop a moving object or a bullet, and then the camera will adjust the aperture to make the light right. There's also night scenes and other variations. I recommend using the automatic setting as you see pictured here because most of the time things happen fast and you want to be able to grab it and shoot. Pictured here is a DSLR camera mounted on a tripod. If you look close, you can see that there's a wireless microphone plugged into the top of it and also a set of earbuds. These come in really handy if you're filming. You can hear noises like motors and HVAC systems running in the earphones that you might not notice with just your ears in the environment. DSLR cameras, they can shoot up to 4K video, but only for short periods of time, maybe 25 or 30 minutes. You don't really need to shoot at 4K. In most cases, if you're doing YouTube videos, 1080p is more than enough. A 4K video takes up 20 times as much file size as 1080p does. Also, you see this little diagram about image sensors. And a lot of people don't really understand how this works. but the original DSLR cameras had 35mm format. In other words, the sensor, the image sensor in the camera, was the same size as a 35mm negative. Now, with the newer, smaller mirrorless cameras, they've actually reduced the size of the sensor. It's called a crop sensor. It's a smaller sensor you can see here. It makes the effective focal length of the lens longer by a factor of 1.6 for Canon. The thing is that the newer sensors are so powerful you don't need the larger one. And you also wanted to note that the one on the very top right corner is actually the size of the sensor in a cell phone. So you can see that there's quite a dramatic difference between using one of these cameras and trying to catch something with your cell phone. When you have an effective larger focal length, a good example would be I carry an 18 to 50 millimeter zoom lens. It has the 35mm focal equivalent of a 28 to 250 millimeter lens when they're used on these smaller cameras with crop sensors. Forensic photography. This is the practice of using photography to document evidence in scenes related to investigations in scientific analysis. I pictured here a ruler, a tape measure, and a set of calipers. Anytime you're in a situation where you're filming something particularly small that might be laid out on a table or something, it makes sense to roll out one of these tape measures or put the ruler next to it, or if it's real small, like a ring or something, clasp it in the caliper. This helps to document the size and the dimensions of whatever you're trying to photograph. Next, we're going to look at thermal imaging. This is a monocular that's handheld. It's an infrared scope. It's compact, pocket-sized, and you can mount it on a tripod. Thermal imaging does not detect visible light, but it uses infrared imaging technology to sense temperature differences and create a digital image like the one that you see here of a radiator heater, which was photographed in total darkness. This thermal scope is equipped with a hot spot. You can see what the X is. It shows you the hottest place in the image. It's powered by a 4800 milliamp rechargeable battery that lasts like 10 hours for continuous use outside, and it can be charged with USB-C charging cord. It has an HDMI jack for streaming to a computer, but the camera will only record still images on the SD card. So if you want to photograph something in action, if you connect it to your computer and then record the video with the computer, that will work. The device has a green laser for acquiring or pointing at the target, and it features a 256 by 192 thermal vision sensor and a larger LCD display. When you look in the image, you're basically looking at a miniature television monitor. There's some interesting information on this slide. First of all, at the top, that you can see that the range is 1,061 meters, which is well over a half a mile, where something the size of a man can be identified. On the right, you see it has a 4-power zoom lens. The color palettes are shown here. You've got the iron oxide hot, you've got the red hot, what they call green hot, black hot, and white hot. And these are suitable for different scenarios. These images were shot from 5-story balcony at about 125 yards distance to the target using 2-power zoom. They're all the same location. You can see an individual getting out of a vehicle on the left side of the image. This is a picnic area, and the second individual can be seen on the right side in front of a fire pit. You can see the iron oxide hot, and then in the middle you've got the red hot, and then the green is on the right. If you look carefully, you'll notice that they're all exactly the same image. They're just expressed in different color palette renditions. Personally, I think the iron oxide hot is the best. This is an image that was shot from a balcony 5 stories above the ground, and you can see an individual walking their dog. This image is also in the iron oxide hot mode, and it was shot from a balcony 5 stories above the ground, picturing a vehicle that was parked. Notice the detail inside the roof panels, and you can actually see what appears to be the engine inside the engine compartment. It should be noted that all of these images were shot in total darkness with incredible detail. Last, we're going to talk about night vision. These are clear color starlight night vision cameras. This one's pictured with a 940 nanometer infrared illuminator. Night vision cameras detect very low levels of visible light. We're looking at a Psionics Aurora black digital clear color night vision camera that lets you see well beyond human eyesight and pick up a man-sized target at 150 meters even during the darkest nights using the 2 millilux near moonless starlight night vision capabilities. They operate in the visibility spectrum of 400 to 1100 nanometers. It's designed to record in extreme conditions. It's IP67 water resistant rated and can be submerged for 3 feet for 30 minutes, and it's also resistant to dust and dirt. The usable temperature range is from -4 degrees Fahrenheit to 122 degrees Fahrenheit. They're capable of withstanding a drop of about 1 meter. Wireless connectivity capability, you can stream full color night vision to an iPad or an Android tablet or a phone with the app that's free. They've got a removable 32 gigabyte SD card that you can take it out and plug it into your computer to transfer the images, and they use rechargeable batteries. Here's a quick overview of the operating controls. You can see on the left side, you've got the lens, and that's a manual focusing ring. You've got the scene selection, so you can go from day, night, to twilight. There's a 4-power zoom. You can see the shutter button, and the eyepiece also has a Doppler adjustment. On the right side, you can record video or still images, and you can see how it's set up. You simply dial it to the camera or the little video camera. There's a playback option, and there's also a setting function for things like time, date, and connectivity. We have pictured a 5-watt LED infrared illuminator. This is a 940 nanometer infrared torch, and it's specifically tuned for the Aurora sensor for perfect balance of color and brightness to identify targets out to 150 meters and to recognize targets that are well beyond that. This is basically an infrared light you use to illuminate a subject. The 940 nanometer wavelength is completely invisible to a human eye. It runs on a 18650 rechargeable lithium battery for about 2 hours of continuous use. These things work pretty good for surveillance and certain types of long distance videoing in dark conditions, but we recommend that you do not point an infrared torch at a UAP. There are countless examples of reports where people pointed lasers, bright flashlights, infrared lights, and high-powered spotlights at UAPs, and it never ends well. On this slide, you can see in the top left corner an Aurora black mounted with a suction cup inside of a boat. And the rest of the image you can see that was filmed in total darkness is the type of image that you can capture with this camera. On this slide, you can see an image that was captured by an iPhone, and then on the right side, the Psionics Aurora. The iPhone is almost completely useless here, where the Psionics Aurora provides a very defined color image of the sailboat in total darkness. This is another very interesting image that was filmed in total darkness. It was during a police tactical shooting range training. Irregardless of which one of these cameras you might be using, tripod mounting devices are very important to have. You can see in this picture, we've got a full-size tripod, and then a suction cup clamp, a suction cup that attaches to the mounting arms, and there's also a clamp and a smaller tripod. These things are invaluable in the field. And finally, a really good case to transport and protect your equipment. This particular case has a lid with organizer pockets. The case is hard plastic, weatherproof, waterproof, has wheels, and can be locked. All the equipment we've talked about in the first 3 videos is packed in this case, ready to go on deployment. And don't forget, your vehicle is a very important part of your equipment. The back of an SUV can be used as a staging area and a workstation. It protects you from the elements because the lid keeps the rain and the sun off you. Suction cups, clamps, and tripods can be used to mount equipment to the vehicle and used outside the vehicle, while the laptop inside records data. We hope you really enjoyed this video. This is the 3rd video in our series about equipment used in UAP investigations. The first video was how to produce a kit for UAP field investigations. The second video was about 6 field tests that can be used to establish the close proximity of a UAP or other type of anomalous phenomena. The fourth video in our series is called UAP Investigation, Use of Video Camcorders. All these videos are available free along with 14 other videos we've produced on our YouTube channel. It's at Aerospace Research Ops. Please check out our website at AEROPS.site. You'll be able to find current posts, new information, and a list of advisory board members. Don't forget to like and subscribe to our YouTube channel.